In this video, we really want to focus on the things that we need to know about squares, rectangles, and parallelograms. I've got an example of each of these drawn here as diagrams, and we want to look at the side lengths of these three figures, the interior angle measures, the perimeter, which is the distance around the edge, and the area, which is the amount of area enclosed by the figure. So when we talk about the side lengths of each of these figures, we need to know that the side lengths of a square are all equal to one another. So if I know that the side length of a square is s, let's say I know the length of this side, I automatically know that the length of all three of the other sides is also s. So the length of this side is s, this side is also s, and this side is also s, because by definition, squares have four equal side lengths. So the side lengths of squares, we could say, are all equal. For rectangles, opposite sides have equal side lengths, and we usually define one side as the length, L, and the other side as the width, W. So if I know that this is the length, then the opposite side is also going to have that same measure, and if this side is the width, then the opposite side over here is also going to have the same measure. So if I want to describe side lengths for rectangles, I could say that opposite sides have equal length. And the same is true for parallelograms. Opposite sides will have equal side length. When it comes to the interior angle measures of squares, rectangles, and parallelograms, for squares, we're going to have four 90-degree angles or four right angles. So each corner of the square will be a 90-degree right angle. And the same is true for rectangles. We'll have four 90-degree angles inside the rectangle. No matter what the length and width happen to be, we'll have four right angles. But for a parallelogram, even though we have opposite sides equal to each other in terms of side length, the interior angles don't necessarily have to be 90 degrees. But we do know that opposite angles are equal to each other. So for instance, if we knew that this angle was 100 degrees, then we know that the opposite angle is also 100 degrees. And furthermore, the four interior angles of a parallelogram and a rectangle and a square for that matter will all sum to 360 degrees. For a square and a rectangle, that's obvious because all four corners are 90 degrees, and 90 degrees times 4 is 360 degrees. But that's true for a parallelogram as well. So once we know that this angle is 100 degrees, we know that the opposite angle is 100 degrees, and then we could take 360 degrees and subtract out these two angles. These two total to 200, so 360 minus 200 is 160 degrees, which means then the other two angles are split evenly inside of 160 degrees. So 160 degrees divided by 2 is 80 degrees, so we know both of these are 80 degrees, which means that if we have one angle measure within a parallelogram, we can automatically find all of the angles within the parallelogram. So here we'll just say opposite angles are equal. For the perimeter of each of these figures, which is the distance around the edge, remember we said earlier that the side length of one side of the square was s. Well, all four side lengths are equal, so we have s here, s, and s. So the perimeter, the distance around, will be 4 multiplied by s. So the perimeter will be 4s if one side length is equal to s. For a rectangle, we've defined one side as the length, the other side as the width. So halfway around the rectangle will be the length plus the width. So we can say length plus width. And then if we multiply that by 2, then we'll get the full perimeter around the entire rectangle, because remember that opposite sides are congruent. So we have length, and we have width and width. So we have to add 2 lengths and 2 widths together to get the full perimeter, or add the length and the width together and then multiply that by 2, and that'll give us the perimeter of the rectangle. And then for the parallelogram, we define one side as the length. We define this slanted side here as the width, and then the perimeter is the same as the rectangle. It's 2 multiplied by the sum of the length plus the width. And that's because just like the rectangle, opposite sides are congruent, so we have 2 length measures and 2 width measures. And then finally, for the area, to get the area of a square, we simply multiply the length by the height here. But we know that the side length is s all the way around, so we would say s multiplied by s is s squared. So the area will be s squared. For the rectangle, we multiply the length by the width, so the area will be length multiplied by width, or L times W. And for the parallelogram, this is the only one that's tricky. We know that we have one side the length and then the other slanted side the width. But to find the area, we actually don't multiply those two together. We need a third measure here, which we call the height, and that's this distance right here, so let's say we call that the height. To find the area, we want to multiply the length by the height, and that will give us the area of the parallelogram.